Okay, good morning everybody. It is Wednesday for me, but I'm going to record this now, upload it, and then you guys will have it for Thursday. So today, what we want to do is talk about the review, so that way if you want to go back and watch the review, it should help you significantly with the quiz, the test that I'm going to give on Friday. Okay, so let's take a look at it. So to determine the domain. So in number one, what we want to do is look at all the values of x can be, but what I noticed right off the bat is x cannot be 4, because you can't divide by 0, makes Cookie and Monster unhappy. But the domain would be everything else. We'd say x is equal to all real numbers except x cannot equal 4, because 4 minus 4 is 0, can't divide by 0. Okay. Number two, it's a square root. Okay, and we're looking for real numbers, not I. So what we want to do is make sure that what's inside the square root, 2x plus 10, is always going to stay positive. So if I set the 2x plus 10 is greater than or equal to 0 to solve, minus 10, divide by 2, so x has got to be greater than or equal to negative 5, and that would be my domain. Alright, everything greater than negative 5. Negative 5 makes it 0, negative 6, you're in trouble. Okay, number 3, what I'm going to do is factor, because I can't divide by 0, so because it's an x squared, there will be two values. So if I go x next, minus 4 and plus 2 makes negative 8, and when I add them I get my negative 2. However, that tells me that x cannot equal both 4 and x cannot equal negative 2. But I got to remember that x can equal everything else. So the domain is x equals all real numbers except 4 and negative 2. Okay. All right, number 3, piecewise graph. So let's take a look at this. We haven't done these for a while. We did this at the very beginning of this chapter, so it's a little bit of a review. To do this, I'm going to go ahead and put in my boundaries first. My boundaries are going to be found at negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 7 for x. Negative 3 for x. A positive 2 for x, and a 6. 2, 3, 4, 5, 6. Okay. Now these are like invisible lines, but I like to put them in because it helps me get a boundary. Okay. And then y equals 7. Let me see. I need a pencil so that I can erase. Y equals 3. Y equals 3 exists between negative 7 and negative 3. So if I go to a height of 3, that's here. And that's going to exist in here, but it's not going to be the whole thing. Solid dot because it is including negative 7 and it's including negative 3. Okay. X squared minus 6 is a parabola starting down at negative 6. 1, 2, 3, 4, 5, 6. And then I'm going to go, my usual parabola. 1, 1, 2, 1, 2, 3, 4. 1, 1, 1, 2, 3, 4. Then 5, 6, 7, 8, 9. What do you know? Here's my parabola, and it's just within negative 3 and 2. Okay, solid dot. That one fills a dot. And then finally, 2 minus 1/2 start at 2. Down 1 over 2, down 1 over 2, down 1 over 2. And so then this graph looks like this between 2 and negative 6. Now these aren't connected, but they don't have to connect. And there it is. Okay, so there is my graph right. Oh, I'm off. No, I'm not. No, I'm not. 2, down 1 over 2. I got it. Okay, so domain. Domain seems to go from a negative 7 all the way across to a positive 6. My domain is negative 7, less than or equal to x, less than or equal to 6. And my range has a height of negative 6. And goes all the way up to a height of 3. Okay, that's what I have. All right, that's my piecewise graph. 5. Okay, let's just use the graph. F of 3. 3 is an x value on, so I'm going to go to 1, 2, 3. 1, 2, 3. And the corresponding answer is its y value, which is height 0. Let me use a different color. Why not? Okay. F of negative 4. Okay, we go back to 1, 2, 3, 4. That's my x value. The answer is the corresponding y value, which is the height, which is a negative 2. F of g g plus f of negative 1. So what I'm going to do is go and use my graph on both sides. So first of all, g of negative 1 is equal to 1, because it's my g graph. Go back to negative 1. Its height is 1. F of negative 1 is 0. Go to 0 on the f graph is 0. And if I add those two, 1 plus 0, I get 1. Okay, that's the answer for f, for g plus f of negative 1. Okay, now if we have to graph negative 2 of f of x, I'm just going to do it on this graph. I'll do it two different colors so you can see it. It's going to be upside down and twice as tall. Okay, so that means this point's going to go here, but up to 4. This point's going to go upside down, but down to negative 4. This point's going to go up, flip up because of the negative, and go up to 4. This point flips because the negative goes down to negative 4. And you hopefully can see what the graph looks like. So it looks more like this. Okay. And there it is. Okay. D. Okay, now we do a different color for f of 2x. So do f of 2x, we need to put, squish it. We're going to squish it. So we need to put two curves in the space of 1. So we're actually going to make it half as wide, okay? Half as wide. And I might put this on another piece of graph paper because it's just getting a little bit squishy here. So, all right, give me a second to put this on here, number 5. And this is 5e, f of 2x. All right, and I'll slide this up. So, if I'm going to do this, I need to put two curves in the space of 1. How does that happen? Well, you have to make it half as wide. You got to squish it to fit 2 in. I don't know if that makes sense. Hopefully it does. So what I do is if I have to do that, I'm just going to bring everything in, all the widths. So I'm going to take, let me get a different color. How about green? Yeah, I like green. So this point right here is going to come into 1. So this point is going to come into 1. This point at 1, 2, 3 is going to come into 1 and a half. Half is wide. This point at 1, 2, 3, 4 is going to come into negative 2. I'm kind of getting the idea. It's going to kind of look like this. This point at negative 1 goes to 1/2. This point here is at negative 2, comes into negative 1. And hopefully you guys can see it's going to look like this. It's going to go, okay, so it's going to be half as wide. So what I do, I had to have made a mistake somewhere. Oh yeah, this has got to go down to here. I did make a mistake. There we go. My goodness. Good thing I have white out, huh? So what I have, after I fix my mistake, because I did make a mistake, so it's all good though. There we go. What I have is two curves in the space of 1 curve. Okay, hopefully that you can see that. Okay, and of course it just keeps going on and on and on because it's periodic. Okay, all right. Number 6. So number 6 says we've got f of x, g of x, and h of x. Okay, so what we're going to do first, the first one is we're going to take and plug, read from the inside out. Okay, put 6 into f. So 6 goes into here. So I have a square root of 6 minus 5, which means 1. Square root of 1 is 1, okay? And then I'm going to take 1 and plug it into g. So 1 into g, I'm going to go 2 times 1 plus 6, which is 2 times 1 is 2, plus 6 is 8. So that's my answer is 8, okay? Okay, rewind the video if that confuses you, okay? B. Take negative 2 and plug it into h. So read from the inside. So take negative 2 and plug it into h. So I'm going to go negative 2 squared plus 1 is 4, which is 5. And take 5 and plug it into g. So I'm going to go 2 times 5 plus 6, which is 10, plus 6 is 16. Okay. Now this one we're going to plug it into 3 different things. First I'll plug it into f, then I'll take that answer, plug it into h, then I'll take that answer and plug it into g. So we'll work our way out. So f of 21. So put 21 right in here. So I'm going to go square root of 21 minus 5, which is 16. Square root of 16 is 4, okay? So now I take 4 and plug it into h. So I'll take 4 and plug it into h. So I'll go a 4 squared plus 1. 16 plus 1 is 17. So I'll take 17 and I'll plug it into g. Okay, here's g. So we're going to go 2 times 17 plus 6. 34 plus 6 is what, 40, I think, if my brain is correct. And there we go. Okay. All right. Again, if you have any questions, if this doesn't make sense to you, just rewind it. Okay. I turn the page. All right. Now I'm going to need to put this on a piece of graph paper, and I'll do that down here. Hold on. Let me get my graph out. So let's graph. Yeah, I want it like this. Okay, graph. So 7. Let's graph it first. X squared minus 7. And I know I'm going to need to erase. So I'm going to use my pencil because I know I'm going to need to erase because what I'm looking for is its inverse. So 1, 2, 3, 4, 5, 6, 7. If I graph this parabola, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to look something like this, right? And again, I just graph these in my head. You guys can graph them in your head also. You can because it's just all the square numbers. Anyhow, here's the problem. Okay, this is not 1-to-1, so this will not have an inverse. So we change the domain. So the first thing I'm going to do is change the domain. So right off the bat, we're going to say, okay, wait a minute, change the domain. We're going to say, let's set x greater than or equal to 0. Okay, that's the first thing I'm going to do. So when I do that, then I'm able to get rid of the back half of my graph. By doing that, my graph becomes 1-to-1, or it will pass the horizontal line test. Now, if I want to graph its inverse, okay, so let's graph its inverse. I can do that. One way to do is get our individual points, 0, negative 7, 1, negative 5. This is 2, negative 3, and this is a 3, 2, and if I wanted to graph those, I'm just going to inverse the points. 0, negative 7 would be 7. Would be negative 7, 0. 1, 2, 3, 4, 5, 6, 7. There's my 0, negative, or my, yeah, negative 7, 0. Boy, oh boy, oh boy. Okay, and then negative 5, 1. 1, 2. No, that's 1, 2, 3, 4, 5, 6. My goodness, you guys. Must be early morning for me. How you think, huh? 1, 2, 3, 4, 5, 6, 1. There we go. I'm sure you're. And then I've got a 2, negative 3, which would be a negative 3, 2, and then I'd have a 2, 3, and here's my inverse graph. Okay, that's f inverse of x. Okay. All right. So far, so good. Now, what's the equation? So if I want the equation of this graph, I'm going to take my y, here's my equation. I'm going to take my y, remember fx and y, equals x squared minus 7. And I'm going to switch my variables. Okay, so I'm going to rewrite this as x equals y squared minus 7. Okay, and I'm going to solve. I need to solve for y, plus 7 plus 7. Okay, square root, but I only want the positive square root, not plus or negative, because I changed my domain. So I'm going to have the square root of x plus 7 is equal to y. So I'm going to call that f inverse, because that is my inverse equation, x plus 7. There we go. All right, there's my inverse equation. Got it, I'm cruising. Okay, now let's look at number 8. Okay, number 8. All right, here we go. So, land is running north from street A, so here's land, he's running that way at 12 miles per hour. Let's call that 12t, that's his distance. And then 8 miles away, Bill is running towards A at 5 miles per hour because Bill's much slower than Landon. So, but he's still 8 miles away, so it'd be 8 minus 5t, minus because Bill's distance is getting smaller as he runs towards the center. Okay, now, as the two boys start running, it creates a right triangle describing the distance between them, okay? So as this continues coming, in, and Lana continues going out. This triangle constantly changes. So the distance between them is constantly changing. Let's call that D. Okay, so I want to describe the distance. First of all, so the distance, using Pythagoras' theorem, would be a squared plus b squared equals c squared. So I'll go distance squared equals a squared plus b squared equals c squared equals a squared, 12t squared, plus b squared, which is a 8 minus 5t squared. And of course, I'm looking for the distance, so I'm going to square root. And I'll go d of t, because it's distance with respect to time. As time progresses, the distance changes. Okay, is equal to a 12t squared plus a 8 minus 5t squared. Okay, now what I'm going to do is graph this. And so I'm going to get my calculator out, looking for my best graph. So I'm just going to go ahead and go on, clear, y equals, clear that. I'll go square root of, you can use decimals. I just like my calculator, 12x quantity squared plus parentheses 8 minus 5x quantity squared. And I should be able to graph this by doing a window. I don't think 100 is going to be way too big. I mean, I think I'd go probably like 25 miles apart at most. Graph it. Oh, okay. So my minimum is in here somewhere. Okay, so it's not very much time at all. I might squeeze my window a little bit. I might squeeze my window. Make that a 1. Let's see what I get. Wow. All right. It's in here somewhere. Okay, so let me go to my calculate my minimum. All right, get all the way over here as far as I can. Try to put the left bound near 0. There you go. Enter. Right bound. Oh, maybe right about there. Enter, enter. So here's what I get for a point. I get about 0.14. I'll round that up. 0.145 and about a 4.6. So my point is about a 0.15 comma 4.6. So let's see what we have. So my x value is really time. That's really time. So my time, because x is time, is t equals 0.15 hours. Okay, but I'm going to change that into minutes, because really we start at 8 o'clock in the morning when we're closest. Okay, so I'll take my 0.15 and I'll multiply it by 60, right, to change it to minutes. Hold on just a second. Let's go 0.15 times 60, and it's about 9 minutes. Okay, about 9 minutes. Lana's so fast that, you know, he cruises right by me. And then the 4.6 is my y, which is my distance. So then my distance is 4.6 miles, right? Miles, because everything's miles per hour. Miles. Okay, there we go. Now the next thing I have to do is, it says, the question really says, at what time? They start at 8 o'clock, at what time? Well, that's easy. 9 minutes later, it's 8:09 a.m. 8:09 a.m. is my answer. And then if you want to look at the extra, which will be on the test, you just have to look at that cylinder problem on page 162. Okay, and that's all I have. Okay, so you guys, I'll see you tomorrow. Have a great day, and we'll work on this tomorrow in class. There we go.